Imagine you're working at a desk. You keep putting things down. A notebook here, a coffee cup there, a stack of paper over there. At first, everything is fine, but eventually you run out of space, so you start throwing away the things you no longer need. Python has to deal with a very similar problem. Your program creates objects constantly. Lists, strings, dictionaries, numbers, custom objects, and eventually some of those objects become completely useless. So what happens to them? Python has a cleanup instinct. It's called garbage collection. Python creates a list object somewhere in memory, and the variable items points to it. As long as something still needs that object, Python needs to keep it around. But now, watch what happens. Items is equal to none. The variable no longer points to the list. If nothing else is pointing to that list, the object has effectively become garbage. It's still occupying memory, but your program has no reason to keep it. Python keeps track of how many references point to an object. Think of it like a popularity counter. 1 reference, the object is still needed. 5 references, definitely keep it. 0 references, nobody needs this anymore. Get rid of it. This mechanism is called reference counting, and in standard C Python, it's one of the main ways memory gets cleaned up. Now, 2 names point to the same list. Python can't delete the list just because A disappears. Why? Because B still needs it. But if we do del A and del B, now there are no references left. The object has been cleaned up. It's almost like a room becoming empty. Once nobody is using it, there's no reason to keep paying rent. But there's a catch. What if objects point to each other? Now A points to B and B points back to A. It's a little loop. Even if nothing else in the program can reach either object, they still point to each other. Their reference counts don't necessarily fall to 0, so simple reference counting isn't enough. This is where Python's cyclical garbage collector becomes important. It can look for groups of objects that reference one another, but aren't actually reachable from the rest of your program. If they are truly unreachable, Python can clean them up. It's like walking into a room and realizing everyone inside is talking to someone else, but nobody outside the room is connected to them anymore. The entire group can go. And this is important because memory isn't infinite. If your program created objects forever without cleaning anything up, eventually it would run out of memory. Garbage collection helps prevent that. It continuously helps Python answer a simple question: does anyone still need this? If the answer is no, the memory can eventually be reclaimed.